medcram.com.
Welcome to another MedCram COVID-19 update. And I wanted to make this short video because I found some very interesting information that I want to pass along to you. So we're going to jump right to it. And so if you're looking for a great review article on vitamin D and general human health, this is the article that you're going to want. And it also has an update about COVID-19 and some recommendations. So we've talked about vitamin D a lot. You can see some of our previous videos if you'd like to. Vitamin D is almost like a hormone. It is a lipid-soluble vitamin. It is derived from a cholesterol derivative, and it requires ultraviolet radiation to convert the cholesterol derivative into the 25-hydroxyvitamin D. From there, the body metabolizes it into 1,25-dihydroxyvitamin D into its active form, but many of these things are actually used. So back to this article, it has almost 200 references, and it hits on multiple topics, which is very germane because just last week there was a paper published that showed a reduction in all-cause mortality associated with vitamin D levels 45 to 60. And here is that article titled Vitamin D Status and Risk of All-Cause and Cause-Specific Mortality in a Large Cohort, Results from the UK Biobank. And what were the results? After a median follow-up of about 9 years, over 10,000 deaths occurred, including 18.1% due to cardiovascular disease, 56% due to cancer. The multivariate analysis revealed nonlinear inverse associations with a decrease in mortality risk appearing to level off at 60 nanomoles per liter of 25-hydroxyvitamin D for all-cause and cardiovascular deaths, and at 45 nanomoles per liter for cancer deaths. Compared to participants with 25-hydroxyvitamin D levels below those cutoffs, those with higher concentrations had a 17% lower risk for all-cause mortality, with a hazard ratio of 0.83, a 23% lower risk for cardiovascular mortality, with a hazard ratio of 0.77, and an 11% lower risk for cancer mortality, hazard rate as 0.89. So their conclusion was that higher 25-hydroxyvitamin D concentrations are non-linearly associated with lower risk of all-cause cardiovascular disease and cancer mortality. The thresholds of 45 to 60 nanomoles per liter might represent an intervention target to reduce overall risk of premature death, which needs further confirmation in large clinical trials. So what they're saying here is this is a retrospective study, a very large retrospective study, looking at a number of patients. As it turns out, over 365,000 participants over almost 10 years where they looked at these patients, and they were able to see this difference in vitamin D levels. Back to our article. If we look at this, we'll see that the article actually breaks down an introduction on vitamin D, as we've talked about. What are the causes and associated diseases of vitamin D? The physiology of vitamin D, which I'm not going to get into at this point. Its skeletal effects, and healthy serum vitamin D and 25-hydroxyvitamin D levels. And then it gets into stuff that's very interesting. For instance, the effects of vitamin D on innate immunity. And they mention here that it also exhibits direct antiviral activities against many respiratory viruses by disrupting viral envelopes and altering viability of host target cells. This process is especially robust in granulomatous inflammation, such as TB, fungal infections, sarcoidosis, and some lymphomas. They also talk about the different types of cell types, B cells, Th1, Th17, etc., and antigen-presenting cells and natural killer cells. But what I became very interested in, because of what we've been talking about, is this section on endothelial function and vascular permeability. Now take a look at this. A number of experimental studies have shown that vitamin D and its metabolites modulate endothelial function and vascular permeability via multiple genomic and extragenomic pathways. What they mean there is that vitamin D may actually directly cause something, or it may upregulate the promoter for transcription of certain genes. And they found this, that 25-hydroxyvitamin D3 and 125-dihydroxyvitamin D3 non-genomically, meaning directly, stabilize vascular endothelium, and that vitamin D3, normally circulating at about 100 times higher level than the 125-dihydroxyvitamin D3, was at least 10 times more potent than 1,25-dihydroxyvitamin D3 and more than 1,000 times more potent than 25-hydroxyvitamin D3 in stabilizing the endothelium. And if we're correct about our hypothesis, we need to be able to stabilize the endothelium. This may be the reason why vitamin D is associated with a lower risk of mortality in COVID-19. A lot of people have been talking about nitric oxide inhalation and whether or not this could enable and help patients with COVID-19. Well, studies have shown that 1,25-dihydroxyvitamin D is a transcriptional regulator of endothelial nitric oxide synthase, which causes upregulation of eNOS gene expression and increases endothelial production of nitric oxide. So here's a connection between nitric oxide and vitamin D3 levels. Furthermore, they noticed that this effect of 1,25-dihydroxyvitamin D3 occurred within a minute of administering the compound, implying that it wasn't being used in terms of transcriptional modification by a promoter, which would take a lot more time. There's a direct, it seems, component to the 1,25-dihydroxyvitamin D and the activation of nitric oxide. So what's the summation regarding endothelium? Taken together, it is evident that vitamin D and its metabolites exert pleiotropic effects on the vascular endothelium that are protective against vascular dysfunction and tissue injury as a result of local and systemic inflammation. This is exactly what we want to have in a patient with COVID-19 if our hypothesis is correct. We've been talking about vaccines and immunity and antibodies. Well, vitamin D has an effect on adaptive immunity. It has an effect on T lymphocytes. There is some question about whether or not helper T cells and memory T cells remember this infection. Well, there is an effect of vitamin D on that. There's also an effect on the B lymphocytes. And these B lymphocytes give rise to plasma cells, and it's these plasma cells that give rise to antibodies. And then this review article goes into a number of other things, including immune-related diseases like psoriasis, like type 1 diabetes, like multiple sclerosis, like inflammatory bowel diseases, like Crohn's, ulcerative colitis, etc. And it all shows very good effects. Also talks about rheumatoid arthritis and even tuberculosis. Talks about sepsis and critical illness in terms of randomized controlled trials. And then, of course, what we want to learn about, which is respiratory viral infections and, yes, COVID-19. Remember, this paper was published literally in the last day or so. So the question for those that say, well, do we actually have any randomized controlled trials that show that vitamin D works in reducing acute respiratory infections? Well, here we go. One of the proposed explanations is that the seasonal outbreak could be due to a seasonal variation in circulating levels of 25-hydroxy-D, which reaches the lowest levels in the winter. Several studies have supported this hypothesis as they reported the independent association between low-level serum 25-hydroxyvitamin D and the incidence and severity of respiratory tract infections in children and adults. A prospective cohort study in healthy adults living in New England showed a twofold reduction in the risk of developing acute respiratory tract infections in those with serum 25-hydroxyvitamin D levels of 38 nanograms per milliliter, which is 95 nanomoles per liter or more. So in this case, they weren't supplemented, but they followed those that had higher levels, and it showed that there was a twofold reduction in the risk of developing acute respiratory tract infections. COVID is an acute respiratory tract infection. Now, it wasn't there as part of those acute respiratory tract infections, but it belongs to that group of acute respiratory tract infections. And we see prospectively that a higher vitamin D level is protective from those. Children that were aged 2 years and less were 1.7 times higher likelihood of requiring hospitalization for an acute respiratory tract infection. So what is it that vitamin D is proposed to be doing? It seems as though that when respiratory viruses enter the respiratory epithelium via the specific entry receptors, whether it be ACE2 or what have you, it causes cellular and tissue damages and triggers the innate and adaptive immune systems both. which then result in airway and systemic inflammation, and in severe cases, life-threatening sepsis or acute respiratory distress syndrome. 1,25-dihydroxyvitamin D, the active form of vitamin D, not only has antiviral activities, but it also modulates inflammatory responses to viral infections by stimulating cathelicidin release, modulation of a toll-like receptor expression, and natural killer cell function, as well as suppressing overexpression of pro-inflammatory cytokines. And as we reported here at MedCram, a recent meta-analysis of 25 randomized controlled trials showed that supplementation of vitamin D2 or D3 can protect against the development of acute respiratory tract infections compared to placebo. They also mentioned in this paper that symptomatic infection, morbidity, and mortality observed in African Americans and obese individuals suggest the possible impact of vitamin D on the host response and susceptibility to infection, as obese and Black individuals are known to have an elevated risk for vitamin D deficiency. And they mentioned that it has been proposed that supplementation of vitamin D can reduce the risk and severity of COVID-19 infection. There's a number of references to that. Then the authors go out on a limb and suggest the following. They say, although the efficacy of vitamin D is still unclear as the results of ongoing clinical trials are still pending, it is advisable that one should maintain adequate vitamin D intake to achieve the desirable serum 25-hydroxy vitamin D level of 40 to 60 nanograms per milliliters, or 100 to 150 nanomoles per liter, in order to minimize the risk and severity of COVID-19 infection. It is well documented that worldwide, on average, approximately 40% of children and adults, have circulating 25-hydroxy vitamin D levels of less than 20 nanograms per milliliter, or 50 nanomoles per liter, and approximately 60% have less than 30 nanograms per milliliter, or 75 nanomoles per liter. Thus, patients presenting to the hospital with COVID-19 are likely to have a vitamin D deficiency or insufficiency. It is therefore reasonable to institute as a standard of care to give at least one single dose of 50,000 units of vitamin D to all COVID-19 patients as soon as possible after being hospitalized. For patients who are intubated and are being fed by a G-tube, they should be treated with a liquid form of vitamin D. Drisdol is a pediatric liquid vitamin D2 formulation that contains 8,000 international units per ml. That can be given daily to these patients to treat vitamin D deficiency. So I wanted to pass this along to you because I know a lot of you are interested in supplementation with vitamin D, and we've talked about it before. I supplement myself with vitamin D. I always recommend all of you checking this out with your doctor. It is possible to overdose on vitamin D, so it's very important that you confer with your doctor about vitamin D supplementation. We'll provide links in the description below to this paper and also the paper talking about all-cause mortality being reduced. And again, don't forget to join us at medcram.com. Thanks for joining us. Please take a moment to leave a comment and subscribe to this channel if you haven't already. We'll be back soon for our next update.